Hello and welcome. Tonight, we'll be exploring whether humans were the first advanced civilization on Earth. For most of our lives, it is easy to imagine civilization as something that begins with us, with cities, written history, machines, and the familiar world surrounding us. But Earth is unimaginably older than humanity, and the brief moment occupied by modern civilization is almost nothing compared with the age of the planet. So, if Earth has been here for more than 4 billion years, what might have happened during all those quiet ages before we arrived? So, find a comfortable place to rest, and let's gently begin our journey into one of the most fascinating questions in science. Imagine for a moment that you could look down upon Earth from far above, not simply seeing its continents and oceans, but watching its entire history unfold. You would see a planet being born from fire and rock. You would watch oceans gather beneath unfamiliar skies. You would see the first simple forms of life appear, long before forests, animals, or anything resembling a human being. Then, slowly, over immense stretches of time, life would change. New forms would appear, others would disappear, oceans would rise and retreat, mountains would grow and wear away, continents would move across the surface of the planet so slowly that a human lifetime would barely register. And then, very near the end of this enormous story, something extraordinary would happen. A small species of primate would begin making tools. It would learn to control fire. It would communicate through increasingly complex language. It would build shelters, villages, roads, cities, and eventually machines capable of reaching beyond the atmosphere. That species would be us, Homo sapiens. Modern humans have existed for roughly 300,000 years, while Earth itself is more than 4 billion years old. The difference is difficult to feel when we simply hear the numbers. 300,000 years sounds enormous, 4 billion years sounds enormous too. But placed beside one another, they tell a very different story. If the entire history of Earth were compressed into a single long night, the appearance of modern humans would occur almost at the very end, perhaps during the quiet moments just before dawn, and everything we call civilization would arrive even later: cities, writing, agriculture, industry, electricity, computers, the internet. All of it would occupy only a tiny flicker of the planet's existence. This is one of the reasons the question of earlier civilizations is so intriguing. Not because science has discovered evidence that another industrial civilization existed before us. It has not. There is currently no direct evidence establishing that an industrial civilization lived on Earth millions of years before modern humans. The source material itself emphasizes this uncertainty. Instead, the interesting question begins with something much simpler. How much of Earth's past can we actually see? We often imagine history as though it were a vast library. Every civilization writes its story into books, buildings, roads, monuments, and machines. But Earth does not behave like a quiet library. It is more like a book whose pages are constantly being turned, rewritten, buried, folded, and sometimes lost. Rain wears away stone. Roots push through old walls. Rivers move soil from one place to another. Oceans rise and retreat. Sediments slowly cover ancient landscapes. And deep beneath the surface, parts of Earth's crust can disappear into the planet itself. Over enormous periods of time, even something that once seemed permanent can become difficult to recognize. This is important because the word civilization can make us imagine something very specific. We tend to picture cities, factories, roads, machines, tall buildings. But intelligence and civilization are not necessarily the same thing. An intelligent species does not have to become an industrial society. It might develop sophisticated communication, social organization, memory, culture, or tools without ever building enormous cities. And even if a society did become technologically advanced, its history would not necessarily move in a straight line forever. Knowledge can be forgotten. Techniques can disappear. Entire traditions can end when the people who carried them are gone. The source material gives us a useful thought experiment here. It asks whether evolution itself might have taken a very different path if certain events in Earth's history had unfolded differently. One particularly dramatic example is the asteroid impact about 66 million years ago, an event associated with the end of the age of non-avian dinosaurs. We sometimes look backward and imagine that humanity was destined to appear, but evolution does not work like a carefully written script. It is shaped by countless changes, accidents, environmental pressures, extinctions, and opportunities. If one major event had unfolded differently, the dominant forms of life on Earth today could have been very different. This does not mean that dinosaurs were destined to become intelligent beings. There is no evidence that they were on the path toward building cities or machines. It is simply a reminder that our existence was not necessarily the only possible outcome. The history of life could have followed many different paths, and that makes the age of Earth feel even more mysterious. Perhaps the most important distinction is this. We know that intelligent technological life appeared here once. We know that it appeared remarkably recently. We know that Earth has existed for billions of years before us. But we do not have a complete record of everything that happened during that immense interval. That does not prove that another civilization existed. It simply reminds us how enormous the unknown still is. Somewhere beneath the oceans, beneath forests and deserts, beneath layers of soil and stone, are traces of countless lives that came before us. Most were never civilizations. Most were never intelligent in anything resembling the human sense, and yet each was part of the same long experiment of life. So perhaps the question should not begin with Atlantis, mysterious monuments, or vanished cities. Perhaps it should begin much earlier, with the planet itself. Because before we can ask whether another civilization disappeared, we first have to understand something more fundamental. We have to understand how easily an ancient world can disappear from view. And as we slowly follow that thought toward the distant coastlines and landscapes of Earth's past, we begin to discover something quietly remarkable. Some worlds really have disappeared beneath the waves. Some landscapes that once stood beneath the open sky now rest in darkness beneath the ocean. And sometimes, the line between a lost landscape and a lost human story can become surprisingly difficult to see. There is something quietly unsettling about looking at the ocean and remembering that the coastline has never been exactly where it is today. The shore may seem permanent when you stand beside it. The sand is beneath your feet. The waves arrive, one after another. The horizon seems unchanged, but over thousands of years, the relationship between land and sea can shift dramatically. Places where people once walked, hunted, traded, built homes and watched the sunrise can eventually become part of the seafloor. This is not speculation. It is a real consequence of changing climate, changing ice sheets, and changing sea levels. During the last ice age, enormous amounts of water were locked away in continental ice. As the planet warmed, much of that ice melted, and the oceans rose. Landscapes that had once been dry became shallow seas. Imagine standing on one of those landscapes thousands of years ago. Perhaps there is a small settlement nearby. People are preparing food. Children are moving between simple shelters. Someone is watching the changing shoreline. The sea may seem distant, but generation by generation, the water moves closer. A familiar piece of land becomes a marsh. The marsh becomes a lagoon. And eventually, the place where those people lived disappears beneath the water. No great explosion is necessary. No dramatic final moment is required. Sometimes, a landscape simply becomes part of the sea. And this is where one of humanity's oldest stories begins to feel strangely familiar: Atlantis. The story comes to us primarily through the writings of the ancient Greek philosopher Plato. In his dialogues, Plato described Atlantis as a powerful island civilization that was eventually destroyed and submerged. For centuries, people have wondered whether this story was based on a real place. Was Atlantis an actual civilization? Was it inspired by a natural disaster? Was it simply a philosophical story created by Plato? Science has not confirmed the existence of Atlantis. There is no accepted archaeological evidence showing that the legendary civilization described by Plato existed as he presented it. And yet, there is an interesting distinction here. Atlantis itself remains unconfirmed, but the idea of human landscapes disappearing beneath the sea is completely real. That distinction matters. A real geological process does not automatically validate a legendary civilization, but it does remind us that the ancient world was not limited to the landscapes we can see today. There are places beneath the ocean that were once dry land, and some of those places were once inhabited. One of the most important examples comes from the enormous changes that followed the last ice age. As glaciers melted, sea levels rose around the world. Large areas of continental shelf were gradually flooded. Some of these landscapes had once connected regions that are now separated by water. People could have walked across places that today require a boat or an aircraft to reach. In this sense, the ocean is not simply a boundary between civilizations. Sometimes, it is a blanket covering an older landscape. This brings us to another name that has become closely associated with lost continents: Lemuria. Lemuria began as a 19th century scientific hypothesis, developed during an era when naturalists were trying to explain unusual patterns in the distribution of animals and plants before modern plate tectonics provided a much better framework. The original idea was eventually abandoned by mainstream geology, but the name survived. Over time, Lemuria became connected with stories of a lost continent, ancient civilizations, spiritual traditions, and mysterious origins. The historical story of Lemuria therefore teaches us something useful. Ideas can change as science changes. A hypothesis created to explain one geological puzzle can later become part of an entirely different cultural story. And sometimes, a scientific question can continue living long after its original explanation has been discarded. The modern ocean contains other mysteries too. One of the most famous is the underwater formation near Yonaguni in Japan. From certain angles, the structure appears remarkably geometric. Large terraces seem to form steps. Flat surfaces appear to meet sharp edges. To some observers, it resembles the remains of an ancient monument. Others argue that the formation can be explained largely, or perhaps entirely, by natural geological processes. The important point is not to decide the mystery before examining the evidence. It is to recognize how easily the human mind can look at a strange pattern and begin searching for a human hand behind it. Nature can create remarkably regular shapes. Rock can fracture along predictable planes. Erosion can carve surfaces that look surprisingly architectural. And underwater environments can make interpretation even more difficult. Similar claims have been made about other underwater structures, including formations associated with the waters near India and Cuba. Some have been presented as possible remains of lost civilizations, but many such claims remain controversial, and apparent geometric patterns are not enough by themselves to establish human construction. This gives us another important rule for our journey. Something can be mysterious without being evidence of a lost civilization. Something can be unusual without being artificial. And something can be artificial without necessarily belonging to a civilization more advanced than the people we already know lived there. These distinctions may seem small, but they become very important when we begin looking backward across thousands or even millions of years. because the farther back we travel, the more difficult the evidence becomes to interpret. The ocean hides landscapes, sediment covers old settlements, wood decays, stone breaks, and the memory of a place can disappear long before the place itself completely disappears. Perhaps this is why stories of sunken lands appear so naturally in human imagination. We live beside an ocean that conceals more than it reveals. Every coastline carries layers of history. Some are visible, others are buried, and some may be resting quietly beneath dark water, waiting for someone to notice them. But there is another side to this story. Even when ancient societies remained above the waves, they sometimes left behind things that still make us pause. Huge stones, carefully aligned structures, astronomical monuments, mechanical devices, and knowledge that seems surprisingly sophisticated for its age. The question is not whether ancient people were capable of remarkable things. They clearly were. The more interesting question is how much we may have underestimated them. And as we turn our attention from the landscapes that disappeared beneath the sea to the monuments that remained beneath the open sky, the ancient world begins to look a little less like a simple beginning, and much more like a world filled with people who were patiently learning how to understand, measure, build, and remember. As the waves continue to move quietly over landscapes that were once dry land, it is worth remembering that not every ancient story has disappeared beneath the ocean. Some traces have remained in the open air. They stand beneath the sun. They rest in deserts and valleys. They rise from fields where people have lived for thousands of years, and sometimes they are so large and so carefully constructed that even after centuries of study, they still invite us to pause and wonder how ancient people organized themselves well enough to create them. Perhaps one of the most familiar examples is the Great Pyramid of Giza. From a distance, it can look almost impossibly simple. A mountain of stone, a broad foundation, 4 enormous sides rising toward a single point. But simplicity from a distance can hide extraordinary complexity. The pyramid required enormous quantities of stone to be quarried, transported, positioned, and arranged. Its builders needed to coordinate workers, food, tools, materials, measurements, and time. They needed to understand geometry and direction. They needed to maintain consistency while working on a structure whose scale was far beyond the size of an ordinary building. And perhaps most importantly, they needed generations of accumulated knowledge. The people who built ancient monuments were not working without knowledge simply because they did not possess modern machines. They had their own methods, their own measurements, their own practical understanding of stone, weight, balance, sunlight, geography, and the movement of the sky. When we look at an ancient monument today, it is tempting to compare it directly with modern technology, but that comparison can be misleading. A society does not need computers, cranes, or modern engines to solve difficult engineering problems. Human beings can accomplish remarkable things with simple tools when those tools are combined with time, organization, experience, and thousands of small improvements passed from one generation to another. This becomes even more interesting when we travel to the Andes. At Pumapunku, enormous blocks of stone were shaped with impressive precision. Some surfaces appear remarkably smooth, some joints are carefully fitted, and the scale of the stones naturally encourages questions about how they were quarried, transported, shaped, and assembled. These questions are legitimate, but they do not require us to imagine machines from a lost industrial age. The more useful question is perhaps a quieter one. What can a society accomplish when skilled people spend generations learning how to work with the same material? Imagine a craftsperson teaching a younger person how to shape stone. The lesson is not written in a manual. It is demonstrated by hand. A particular angle is shown. A particular sound from the stone is noticed. A particular tool is chosen. The younger person practices. Years later, That person teaches someone else. Knowledge becomes something that travels through time inside human hands. Eventually, the original discoverer may be forgotten. The technique may become so ordinary that nobody remembers when it began, yet the knowledge remains. This idea helps us understand another remarkable site. Göbekli Tepe, in what is now southeastern Turkey, revealed monumental structures dating to a period much earlier than the large urban civilizations that traditionally dominate our image of ancient history. Its massive carved stones and organized construction challenged older assumptions about what early human communities were capable of. The important lesson is not that Göbekli Tepe was built by an unknown civilization. There is no need for that explanation. The more fascinating lesson is that early human societies were capable of organizing complex projects much earlier than older, simpler models of human history sometimes suggested. People who lived without modern cities could still gather together. They could plan. They could transport heavy stones. They could create symbolic spaces. They could invest enormous effort into something that was not simply about immediate survival. And that tells us something important about the human past. Civilization does not suddenly appear one morning. There is no single moment when people wake up and become sophisticated. Instead, abilities accumulate. Observation becomes knowledge. Knowledge becomes tradition. Tradition becomes technique. And technique can become architecture. The same process can be seen when we look toward the night sky. Long before telescopes, satellites, or digital clocks, people watched the heavens. They noticed that the moon changed in recognizable ways. They watched the sun move across the seasons. They noticed that certain stars returned to familiar positions. They learned that some celestial events followed patterns. Imagine doing this without a printed calendar. You simply look upward, night after night, season after season, year after year. Eventually, patterns that once seemed mysterious become familiar. The sky becomes a kind of clock. Not a clock with hands and numbers, but a vast and slowly moving one. Maya astronomers developed sophisticated systems for observing and calculating celestial cycles. Ancient Egyptian builders and priests also possessed detailed knowledge of the sky and the changing seasons. And at Stonehenge, enormous stones were arranged within a landscape that appears to have had important relationships with the movement of the sun and the changing seasons. None of these examples require knowledge from a lost prehistoric industrial civilization. They demonstrate something both simpler and, in a way, more impressive. Human beings are extremely good at observing patterns. Give a community enough generations, enough patience, and enough reason to pay attention, and the natural world begins to reveal rhythms that are almost invisible to someone who looks only once. And knowledge can become embedded in physical objects. A stone can remember a direction. A monument can preserve a seasonal pattern. A mechanical device can preserve an astronomical calculation. But there is another side to knowledge. It can also disappear. A technique can be forgotten. A language can vanish. A workshop can close. A tradition can end. A library can be damaged or destroyed. The famous Library of Alexandria has become a symbol of this broader problem, the fragility of human knowledge. We should be careful not to imagine that one fire simply erased the entire ancient world's knowledge in a single moment. History is usually more complicated than that. Libraries decline, collections are scattered, institutions change, texts are copied, lost, or forgotten. Knowledge survives unevenly. And sometimes, a remarkable piece of technology can survive physically even after the intellectual tradition that produced it has become difficult to reconstruct. The Antikythera mechanism offers a striking example. This ancient mechanical device demonstrates an extraordinary level of craftsmanship and astronomical calculation. It reminds us that technological development does not always move smoothly upward. Sometimes knowledge is discovered, then refined, then forgotten, and centuries later, someone has to rediscover how remarkable it once was. This is an important thought to carry with us. A lost technology does not automatically mean a lost civilization. A sophisticated ancient object does not automatically point to an unknown source. Sometimes the explanation is simply that human knowledge is more complicated than the neat story we tell ourselves. It grows, it branches, it disappears, and sometimes, quietly, it returns. Perhaps the ancient world was not filled with impossible mysteries after all. Perhaps it was filled with something more human. Patient observers, skilled builders, careful astronomers, generations of teachers and students. People who looked at stone and learned how to shape it. People who looked at the sky and learned how to remember its rhythm. And as we continue following those traces, another question begins to appear softly in the background. If knowledge can survive for centuries, carried from one generation to another, how much older knowledge might have survived in fragments? And when we find an ancient map, an unusual calculation, or a strange pattern preserved across generations, how can we tell whether we are looking at ordinary human ingenuity, a lost tradition, or simply something we have not yet learned how to understand? When we look at an ancient monument, we are looking at knowledge preserved in stone. But knowledge does not always survive in such a solid form. Sometimes it survives as a drawing, sometimes as a number, sometimes as a story, repeated by generations of people who may no longer remember where the story began. And sometimes it survives as a map. A map is an unusual kind of memory. It takes something enormous, something that cannot fit inside the human mind all at once, and turns it into lines and shapes that can be carried from one person to another. Long before satellites could look down upon Earth, people were already trying to understand the world around them. They watched coastlines, they followed rivers, they crossed deserts, they sailed along familiar shores, they learned where mountains appeared on the horizon, and where certain islands could be found after days at sea. Every journey added another small piece to the mental picture of the world, and over generations those pieces could be copied, corrected, combined, and passed onward. One of the most famous examples in discussions of ancient maps is the map associated with Piri Reis, an Ottoman admiral and cartographer from the 16th century. The map attracts attention because of the geographical information it appears to contain, and because some interpretations have suggested that parts of its southern coastline resemble Antarctica, or an earlier representation of regions now hidden beneath ice. This has sometimes been presented as evidence that ancient people possessed knowledge that should have been impossible for their time. But the story becomes more interesting when we slow down. A map does not necessarily tell us who first discovered every coastline drawn upon it. Maps can be copied from older maps. Older maps can be copied from still older sources. Fragments can be combined, errors can be corrected, and information can travel enormous distances without the original traveler ever meeting the person who eventually receives it. The map itself, therefore, becomes less like a mysterious object and more like a piece of a very long conversation. Some interpretations of the Piri Reis map remain controversial, particularly claims about Antarctica. Those claims should not be treated as established evidence of a prehistoric global civilization. But the broader idea of inherited knowledge is completely reasonable. Human knowledge often survives because one generation gives something to the next. A sailor remembers a dangerous reef. A farmer remembers when the rains usually arrive. An astronomer records the return of a particular celestial pattern. A builder remembers which shape of stone fits best. A storyteller remembers the path taken by ancestors. Over time, these fragments can become surprisingly sophisticated. This is especially important when we think about ancient astronomy. Today, you can look at a phone and instantly know the time. You can ask a computer when the moon will rise. You can find the position of a planet with a few taps. But imagine living in a world without clocks, without satellites, and without printed calendars. If you wanted to understand the seasons, you would have to watch. You would notice where the sun rises. You would notice where it sets. You would watch the length of shadows. You would notice the changing position of stars. And if you watched for long enough, patterns would slowly emerge. The sky would become a kind of enormous clock. Not a clock with hands, not a clock with numbers, but a clock whose movements were measured in seasons and generations. This helps us understand the sophistication of Maya astronomy. The Maya developed detailed systems for tracking celestial cycles and constructing calendars. Such knowledge did not require modern telescopes. It required something more ancient: patience, observation, memory, and mathematics passed carefully from one generation to another. The same principle helps explain why ancient Egyptian culture could develop strong connections between architecture, the calendar, the seasons, and the sky. And Stonehenge offers another striking example of people arranging massive stones in ways that appear connected with the movements of the sun and the seasonal cycle. When we stand before such monuments today, it is tempting to imagine that there must have been some hidden source of knowledge behind them. But perhaps there is another possibility. Perhaps the source was simply time. Thousands of observations, thousands of corrections, thousands of conversations between people who understood one small part of the pattern and passed it onward. A single generation might notice something. The next generation remembers it. The generation after that improves it. And eventually, the knowledge becomes so refined that the final result looks almost mysterious. This is one reason it is dangerous to underestimate ancient people. We live surrounded by technologies that hide enormous amounts of accumulated knowledge. When you use a phone, you do not need to understand how every component was invented. When you turn on a light, you do not need to know the entire history of electrical engineering. When you look at a modern map, you do not need to know the lives of all the people who measured the landscapes that came before you. You simply inherit the result. Ancient people did the same thing. Their tools were different. Their information moved more slowly. Their observations often had to be repeated by hand. But the basic process was familiar. Someone discovers, someone remembers, someone teaches, someone improves, and someone eventually inherits the finished knowledge. This leads to a subtle problem when we investigate the distant past. Suppose we discover an ancient object containing information that seems surprisingly advanced. How do we know whether it came from a lost civilization? How do we know whether it was developed independently? How do we know whether it was inherited from an older culture, or whether we are simply misunderstanding what the object was designed to do? Those questions are not signs that archaeology has failed. They are part of how archaeology works. Evidence needs context. A strange object is not enough. A remarkable alignment is not enough. A sophisticated calculation is not enough. And an ancient map is not enough. We need multiple lines of evidence that point toward the same explanation. This distinction becomes especially important when we encounter claims about ancient knowledge that seem almost impossible. Something can be impressive without being mysterious. Something can be mysterious without being evidence of a lost civilization. And something can be genuinely unexplained without requiring an extraordinary answer. There is also something beautiful in the possibility that knowledge can survive in this quiet way. A person who lived thousands of years ago may have looked toward the same stars you can see tonight. They may have wondered when the seasons would change. They may have watched the moon disappear into darkness and slowly return. They may have tried to understand the rhythms of the world, and perhaps someone taught them what an earlier generation had learned. Then they taught someone else. Across centuries, across languages, across changing landscapes, fragments of understanding continued moving forward, not perfectly, not continuously, but enough to leave traces. And this brings us closer to one of the most important questions in our journey. What happens when that chain of memory is broken? What happens when a society disappears? Its knowledge becomes scattered, and the landscape around it begins to change. Because sometimes, history does not lose a civilization all at once. Sometimes it loses it one piece at a time. A building disappears, then a language, then a technique, then the memory of why a monument was built. And eventually, all that remains may be a few stones, a faded map, or a pattern whose meaning we can only guess. And beyond those quiet fragments lies a much larger force, one capable of changing not only human societies, but the entire surface of the planet. The earth beneath our feet can feel remarkably stable. You wake in the same room. The street outside is familiar. The horizon seems to remain where it has always been. The seasons arrive in their usual order. And because human lives are short compared with the age of the planet, it is easy to imagine that the world itself is permanent. But Earth has never been still. Its mountains rise and slowly wear away. Its rivers change their courses. Its coastlines move. Ice sheets expand and retreat. Volcanoes reshape landscapes. And sometimes, in rare moments, something happens that changes the direction of life on the entire planet. For any civilization trying to survive here, the environment is not simply a background, it is part of the story. One of the clearest reminders of this comes from an event roughly 66 million years ago. A large asteroid struck what is now the Yucatan region of Mexico. The impact was enormous. It released tremendous amounts of energy and disturbed the atmosphere, climate, and ecosystems on a planetary scale. The consequences were devastating for countless species. Among the victims were the non-avian dinosaurs that had dominated terrestrial ecosystems for so long. We sometimes think of extinction as a slow disappearance. One species becomes less common. Its numbers decline. Eventually, it is gone. But some extinctions can be different. A single event can rapidly alter the conditions upon which entire ecosystems depend. The world after the impact was not simply the same world with fewer dinosaurs. It was a different world. Different opportunities appeared. Different species survived. Different evolutionary paths became possible. And over the immense span of time that followed, mammals diversified in ways that eventually contributed to the world in which humans would appear. This does not mean the asteroid impact was somehow destined to create humanity. Evolution does not work with a predetermined destination, but it reminds us how dependent the history of life can be on events that no creature can control. If that asteroid had never arrived, Earth's history might have unfolded very differently. Perhaps some other species would eventually have become dominant. Perhaps intelligence would have developed along another branch of the tree of life. Or perhaps no species would ever have built anything resembling human civilization. We simply do not know. And this uncertainty becomes important when we imagine civilizations existing deep in the past. Because if a society develops on Earth, it does not live on a perfectly stable stage. It lives on a moving planet. Volcanoes can erupt. Earthquakes can destroy settlements. Floods can reshape valleys. Droughts can transform food systems. And changes in climate can gradually make familiar environments difficult to inhabit. Sometimes the change is slow enough for people to adapt. Sometimes it happens more quickly. The end of the last ice age provides an especially interesting example. As enormous ice sheets melted, sea levels rose. Coastlines moved inland, river systems changed, habitats shifted. For people living near the sea, a landscape that had remained familiar for generations could slowly become something entirely different. A settlement might not be destroyed in one dramatic moment. Instead, people could simply leave. The shoreline could continue moving. Sediment could cover what remained. And eventually, the place might become difficult to recognize. Climate change can also affect civilization through food. A society may depend upon particular crops, predictable rainfall, grazing lands, or seasonal rivers. When those patterns change, the effects can spread outward. A poor harvest can lead to food shortages. Food shortages can create migration. Migration can place pressure on neighboring communities. Political systems can become unstable. What begins as an environmental change can eventually become a social transformation. This is one reason scientists study abrupt climate changes so carefully. One period that often appears in discussions of Earth's past is the Younger Dryas, a relatively sudden return to colder conditions near the end of the last ice age. The causes and precise mechanisms behind this climatic episode are subjects of scientific research. Some researchers have proposed that an extraterrestrial impact may have contributed to the changes associated with the Younger Dryas, but this remains debated. It is not an established explanation that can simply be treated as settled fact. That distinction matters. The Younger Dryas itself is real. Abrupt climate change is real. The possibility of an impact has been investigated, but the exact relationship between these events remains an area of scientific discussion. And perhaps this is where the mystery becomes more interesting than any dramatic answer, because we do not need a single enormous catastrophe to imagine a civilization disappearing. A society can become vulnerable through a combination of smaller pressures: a changing climate, a failed harvest, a disease, a conflict, a shifting coastline, a volcanic eruption, a prolonged drought. Several pressures arriving close together can be far more damaging than any one of them alone. And even when a civilization collapses, its physical remains do not necessarily disappear immediately. A ruined settlement can remain visible for centuries. Then, vegetation begins to cover it. Rain wears down exposed surfaces. Wind carries away loose material. Soil builds up. Animals move through abandoned streets. Eventually, the landscape begins to look natural again. Given enough time, even the boundary between a settlement and its surrounding environment can become difficult to see. This leads us toward an important distinction. A catastrophe can destroy a civilization, but destroying a civilization is not the same as erasing every trace of it. If an industrial society had existed millions of years ago, we might expect more than ruined buildings. We might expect unusual changes in chemistry. We might expect persistent materials. We might expect alterations in the environment. We might expect some kind of geological fingerprint. And this is where our journey begins, to move away from stories of sunken cities and towards something deeper, because perhaps the greatest threat to an ancient civilization would not have been a single catastrophe. Perhaps it would have been time itself. A ruined building can survive a disaster. A stone monument can survive 1,000 years. But what happens after 1,000,000? What happens after 10 million? At those scales, the Earth itself begins to change the evidence. Layers are buried, rocks are transformed, landscapes disappear, and traces that once seemed obvious become quieter and quieter. The planet does not simply record history, it slowly rewrites it. And if we want to understand whether an ancient technological civilization could ever have vanished without leaving an obvious monument behind, we have to follow that process patiently. We have to imagine the Earth not as a museum preserving every object placed upon it, but as a vast, slowly changing world in which everything is gradually altered. Stone becomes sediment. Sediment becomes rock. Coastlines move. Old surfaces disappear beneath new ones. And somewhere inside those layers, perhaps, the faintest traces of forgotten worlds may remain. There is a strange thought experiment hidden inside the enormous age of Earth. We know that our planet has existed for more than 4 billion years. We know that modern humans have been here for only a tiny fraction of that time. And we know that the geological record is incomplete. So, quietly, almost like a question whispered across a very old landscape, we can ask, what if another technological species had appeared long before us? Not humans, not necessarily anything resembling us, perhaps a completely different form of intelligent life that somehow developed the ability to build, organize, extract energy, and reshape its environment. What would remain after millions of years? This is the question behind what scientists have called the Silurian Hypothesis. The name sounds almost like something from a science fiction novel, but the idea itself was proposed as a serious scientific thought experiment. In 2018, scientists Adam Frank and Gavin Schmidt asked what geological traces an industrial civilization might leave behind if it had existed millions of years before humanity. The purpose was not to claim that such a civilization existed, it was to ask how we would recognize one if it had. And that difference is essential. The Silurian Hypothesis is not evidence. It is a framework for thinking about evidence. Imagine that a technological civilization existed on Earth 10 million years ago. Its cities might have been enormous. Its factories might have transformed the landscape. Its machines might have operated continuously for generations. Perhaps it mined metals. Perhaps it burned large amounts of stored carbon. Perhaps it produced synthetic materials. Perhaps it altered the chemistry of the atmosphere. At the time, these changes could have been obvious. But 10 million years later, almost everything familiar to that civilization could be gone. Buildings would not simply become old, they would become part of geology. Concrete would crack, steel would corrode, glass would break, roads would disappear beneath soil, cities would become buried beneath sediments, rivers would change their courses, vegetation would cover abandoned landscapes, and eventually, tectonic processes would begin to rearrange the deeper layers of the planet. The civilization might disappear as completely as a footprint washed away from a beach, but perhaps not every trace would vanish. This is where the hypothesis becomes scientifically interesting. An industrial civilization might leave behind what we could call a geological fingerprint, not necessarily a recognizable machine, not necessarily a preserved building, instead, perhaps a subtle chemical change, a strange concentration of certain elements, an unusual layer in ancient sediments, a persistent alteration in atmospheric composition, synthetic compounds that do not naturally occur in large quantities, or an abrupt change in the carbon cycle that could not easily be explained by ordinary natural processes. These would not be proof by themselves. Nature is capable of producing many strange chemical patterns, but if several independent clues appeared in the same period, scientists might begin asking whether something unusual had happened. This is similar to the way detectives work. A single footprint may mean very little. A single unusual object may have an ordinary explanation. But if footprints, broken branches, and other independent clues all point in the same direction, the overall picture becomes more interesting. Geology works in a somewhat similar way. Scientists rarely expect one magical piece of evidence to reveal the entire story. They look for patterns, and deep time makes those patterns difficult to interpret. Consider plastic. Modern civilization produces enormous quantities of it. If humanity disappeared tomorrow, much of that material would remain for a long time. But long time is relative. 1 million years is a very different kind of duration. 10 million years is longer still. Most familiar objects would eventually be broken apart, buried, altered, or transformed. Yet some unusual chemical or geological traces might survive. This is why the hypothesis does not focus only on ruins. A civilization that existed millions of years ago might be easier to detect through changes in Earth's chemistry than through the remains of its buildings. There is another fascinating possibility. Perhaps an ancient industrial civilization would have changed the climate. Human industry has already altered atmospheric concentrations of greenhouse gases. If another technological society had done something similar millions of years ago, perhaps some trace of that disturbance would remain inside ancient sediments. But again, the challenge is enormous. Earth's climate changes naturally. Volcanoes release gases, oceans absorb and release carbon, plants alter atmospheric chemistry, continents move, ice ages begin and end. Massive eruptions can transform the atmosphere. So scientists would have to distinguish the fingerprints of natural processes from those produced by technology, and that is not easy. This is one of the most important ideas to keep in mind. The absence of obvious evidence is not automatically proof that something never existed, but neither is the difficulty of finding evidence proof that something did exist. Those two statements can sound similar, but they lead to very different conclusions. Science has to remain comfortable with uncertainty. At present, there is no direct evidence that an industrial civilization existed millions of years before humans. There is no ancient factory waiting beneath the soil. No unmistakable machine has been recovered from rocks millions of years old. No geological signature has been accepted by scientists as the fingerprint of a pre-human technological civilization. So why take the idea seriously at all? Because thought experiments can reveal what evidence we should actually search for. The Silurian Hypothesis asks us to move beyond the image of a lost city. A city is something our imagination understands easily. We picture walls, towers, streets, machines. But geology works differently. Millions of years are capable of reducing enormous structures to scattered fragments. A civilization does not need to leave behind a recognizable skyline in order to have altered the planet. It might leave a chemical whisper instead. And perhaps that is the most haunting part of the idea. Imagine that an ancient civilization really had existed. Imagine its people watching the sunrise over a world that looked completely different from ours. They would have believed their cities were permanent. Their machines would have seemed enduring. Their knowledge might have felt secure, but eventually their civilization would have ended. The buildings would have fallen, the roads would have disappeared, the people would have vanished, and the planet would have continued turning. Millions of years would pass. New species would appear, other species would disappear, mountains would rise, seas would move, and eventually another intelligent species would emerge, us. We would look backward and ask what had happened before, and perhaps the answer would not be waiting in the form of a monument. Perhaps it would be hidden inside a thin layer of ancient rock, quietly preserving a chemical memory of something that happened unimaginably long ago. Or perhaps we would find nothing at all, and that possibility is just as important. Because the Silurian Hypothesis does not tell us that an earlier civilization existed. It simply asks us to consider how we would know if one had. There is a quiet way to test the question we have been exploring. Instead of imagining a civilization that disappeared millions of years ago, imagine something much closer. Imagine that humanity simply stopped. No warning, no final announcement. No one left to maintain the roads, repair the power stations, clean the buildings, or guide the machines. The cities would still be standing. For a while, lights would go out, water systems would stop functioning, plants would begin pushing through cracks in concrete, rain would enter buildings through damaged roofs, windows would break, metal would begin to rust. The familiar shape of a modern city would slowly soften beneath the returning landscape. At first, the changes would be obvious. After a few years, abandoned buildings would begin to deteriorate. After decades, vegetation would spread through streets and empty structures. After centuries, many materials would be damaged beyond recognition. After thousands of years, only the more durable remains would continue to tell the story. And if enough time passed, even those traces would become difficult to interpret. This thought experiment is useful because it reminds us of something we often forget. Civilization is not simply the collection of buildings and machines around us. It is an enormous maintenance system. A city exists because millions of small actions happen every day. Someone repairs a bridge. Someone replaces a damaged cable. Someone pumps water. Someone clears a drain. Someone maintains a railway. Someone checks a power station. Someone writes software. Someone teaches the next generation how everything works. Remove the people, and the system begins to unravel. The modern world is extraordinarily capable, but it is also extraordinarily dependent. Electricity depends on infrastructure. Food depends on agriculture, transportation, storage, and communication. Hospitals depend on power, medicine, equipment, trained workers, and supply chains. Even something as ordinary as clean drinking water depends on an enormous network of pumps, pipes, treatment facilities, and people. We rarely notice this because the system works quietly in the background. But civilization is not a machine that runs forever once switched on. It is more like a garden. It survives because someone keeps tending it. This also changes how we think about ancient civilizations. When we discover an abandoned settlement, we are seeing the final visible layer of a much larger human story. We may find walls, pottery, tools, burial sites, roads, foundations, but we do not see every conversation that took place there. We do not see every skill that was taught. We do not hear the languages spoken in its homes. We do not know every technique used by its craftsmen. Much of a civilization's knowledge is invisible, and invisible knowledge can disappear extremely quickly. Imagine a specialized craft known by only a few people. Perhaps one person knows how to make a particular tool. Another knows how to repair a particular machine. Another remembers an agricultural technique that works during unusually dry years. If those people die without passing their knowledge onward, the technique may disappear. The physical object might remain, but the understanding behind it may be gone. This is why a technologically advanced civilization could, in principle, leave a strangely incomplete archaeological record. Not because every trace would magically vanish, but because different parts of civilization have very different lifespans. Organic materials decay, metal corrodes, buildings collapse, synthetic materials fragment, knowledge disappears, and the geological environment continues changing around everything. Now imagine extending our thought experiment much farther into the future. 100,000 years, 1 million, 10 million. The Earth would no longer look like the world you know. Coastlines would shift, rivers would change, climate patterns would be different, species would evolve and disappear. Some of today's landscapes might no longer exist. A future intelligent species might walk through a region where a modern city once stood and see nothing that immediately resembles a city. Perhaps they would find an unusual concentration of materials, perhaps a strange layer of sediment, perhaps fragments of glass or metal, perhaps a buried structure, but would they understand what they were seeing? They might not even know that the objects belonged together. This is an important lesson. Evidence does not explain itself. A stone foundation does not announce who built it. A metal fragment does not explain what machine it belonged to. A strange chemical layer does not automatically reveal its origin. Interpretation requires context, and context is one of the things time destroys most effectively. This is also why catastrophes matter. A nuclear war, for example, could devastate human civilization without completely destroying the planet. A severe climate shift could disrupt food systems and trigger enormous social changes. A major volcanic eruption could affect agriculture and climate across large regions. A powerful solar storm could severely disrupt modern technological infrastructure. None of these events necessarily needs to eliminate every human being, but they could damage the interconnected systems upon which modern civilization depends. And once those systems begin to fail, recovery would not necessarily be simple. A society that loses electricity might still possess books. A society that loses industrial manufacturing might still possess tools. But if enough interconnected systems disappear together, the knowledge required to rebuild them could become increasingly difficult to preserve. One generation might remember how something worked. The next might remember only fragments. Eventually, the object remains while the knowledge disappears. This is not science fiction. History already contains smaller examples of technologies and techniques that were lost, forgotten, or rediscovered much later. The important difference is scale. The deeper we move into the future, the more time has to work upon the evidence. And that brings us back to our original question. If humanity disappeared, would the Earth remember us? The answer is probably yes, but perhaps not in the way we imagine. The Earth would not preserve a perfect museum of our civilization. It would preserve fragments, a few unusual materials, modified landscapes, changes in atmospheric chemistry, sediments carrying traces of human activity, structures buried beneath later layers. Perhaps some objects would survive, perhaps others would completely disappear. The story would become incomplete, and an incomplete story can be difficult to recognize. This thought experiment does not prove that an earlier technological civilization existed, but it does demonstrate why the search for such a civilization cannot depend entirely on finding an ancient city. A civilization millions of years old might not leave anything that looks like a city. Its most enduring traces could be subtle, quiet, geological, almost invisible. And perhaps this is where the question becomes most interesting. If our own civilization could become difficult to recognize after enough time, then what should we actually search for when examining Earth's ancient past? The answer may lie not in legends, but in the rocks. Not in mysterious stories, but in chemical patterns. Not in one extraordinary object, but in several independent clues that quietly point toward the same event. Because if an earlier technological civilization truly existed, Earth may have remembered it in ways we have not yet learned how to read. After traveling through drowned landscapes, ancient monuments, astronomical knowledge, catastrophes, and the quiet geological fingerprints that might survive for millions of years, we have arrived at the most important part of the question. Not the most dramatic part, not the part with the greatest mystery, but the part that asks us to be honest about what we actually know. Were humans the first advanced civilization on Earth? At the moment, science has no evidence that another industrial civilization existed here before us. That conclusion is important. It means we should not look at every ancient monument and imagine a forgotten technological society. We should not look at every underwater formation and assume that it was built by an unknown people. We should not treat an unusual chemical layer as proof of an ancient industry. And we should not turn an intriguing possibility into a historical fact simply because the possibility is fascinating. But saying that there is no evidence for an earlier industrial civilization is not quite the same as saying that we have explored every corner of Earth's past. We have not. And this is where the question becomes more subtle. The archaeological record is incomplete. The ocean floor remains difficult to investigate in detail. Large parts of Earth's ancient geological history have been altered by erosion, burial, volcanic activity, and the movement of tectonic plates. Some rocks that formed hundreds of millions of years ago have been transformed or recycled. Entire landscapes have disappeared, and countless organisms that once lived on Earth left no obvious trace that we can recognize today. So the scientific position is not a dramatic yes. It is not a dramatic no. It is something quieter. We have no direct evidence that an earlier technological civilization existed, and we currently have no compelling reason to believe that one did. But the question of how such a civilization could be detected is scientifically interesting. That is exactly where the Silurian hypothesis becomes useful. It reminds us that a civilization millions of years old might not leave behind a perfectly preserved city. Instead, researchers might need to search for unusual combinations of evidence, perhaps a geological layer containing an unexpected chemical disturbance, Perhaps an unusual concentration of certain materials. Perhaps traces of rapid environmental change that cannot easily be explained by known natural processes. Perhaps several independent clues appearing together. The important word is independent. Science becomes stronger when different kinds of evidence tell the same story. One strange object can be misleading. One unusual rock can have a natural explanation. One ancient legend can change through centuries of storytelling. But if geology, chemistry, archaeology, and other independent fields all pointed toward the same unexplained event, the case would become much more interesting. This is how science protects itself from the attraction of a good mystery. It does not ask only, could this be true? It also asks, what else could explain it? That second question is sometimes less exciting, but it is often where real discovery begins. Consider Atlantis again. Could an ancient coastal settlement have been submerged by rising sea levels? Absolutely. Did post-Ice Age sea level changes flood enormous areas of formerly dry land? Yes. Does that prove Plato's Atlantis existed exactly as described? No. The first statement is supported by geology. The second remains an open historical question. The same principle applies to Lemuria. The history of the idea is real. The geological explanation that originally motivated the concept has been replaced by modern plate tectonics, and the later stories about an advanced lost continent are not established geological evidence. Or consider the ancient monuments. The Great Pyramid is extraordinary. Pumapunku is extraordinary. Göbekli Tepe transformed our understanding of early monumental construction. Stonehenge reveals sophisticated relationships between architecture, landscape, and the sky. The Antikythera mechanism demonstrates that ancient technological knowledge could be remarkably sophisticated. But none of these discoveries requires a pre-human civilization. In fact, perhaps there is another lesson hidden here. We sometimes create a mystery by underestimating the people who actually built these things. Ancient human beings were not less intelligent simply because they lived thousands of years ago. They had different tools. They had different limitations. But they also had something we still possess: time, curiosity, memory, cooperation, and the ability to pass knowledge from one generation to another. Perhaps the ancient world was stranger than we imagined, but perhaps it was also more human, and there is one final possibility worth considering. Maybe humanity really is the first technological civilization on Earth. Maybe there were no earlier industrial societies. Maybe the long silence before us is exactly what it appears to be. If so, that makes our existence no less extraordinary. In fact, it may make it more precious. For billions of years, Earth existed without cities, without writing, without satellites, without anyone looking back at the planet and wondering where everything came from. Then, in a tiny fraction of geological time, one species developed the ability to study the history of the world that produced it. We became capable of looking into rocks that are billions of years old. We learned to reconstruct extinct ecosystems. We learned to read chemical traces trapped inside ancient sediments. We learned that continents move. We learned that species disappear. We learned that the planet itself has a memory, a very imperfect memory, but a memory nonetheless. And perhaps that is the deepest lesson of this entire journey. The question is not only whether another civilization existed before us. The question is, what kind of trace a civilization leaves behind. A civilization can disappear. A monument can collapse. A city can be buried. A coastline can drown. A language can vanish. A technology can be forgotten. But some consequences may remain, and those consequences may be the quietest parts of history. A thin layer of sediment, a changed chemical pattern, a fragment of stone, a strange object, a story passed from one generation to another, or simply an unanswered question. Tonight, we have followed that question across billions of years. We have imagined ancient coastlines beneath the sea. We have stood beside enormous stones. We have watched ancient people measure the heavens. We have considered the power of asteroids, volcanoes, climate shifts, and time itself. And we have imagined our own civilization becoming ancient enough that another species might one day wonder whether we were ever here. Perhaps they would find our cities. Perhaps they would find only fragments. Perhaps they would understand us. Or perhaps they would look at the traces we left behind and wonder about the civilization that came before them. For now, there is no evidence that another technological civilization came before humanity. But Earth is still full of places we have not completely understood, and the scientific search continues, quietly and patiently. So perhaps the most honest answer is also the most beautiful. We do not know everything that happened here. We know enough to understand that humanity arrived very late. We know enough to understand that civilizations can be fragile. And we know enough to realize that the planet beneath us is far older, deeper, and stranger than any human story. And if you are listening in the quiet hours of the night, perhaps you can let that thought become smaller and softer. You do not need to solve the mystery tonight. The Earth has had billions of years to keep its secrets. For now, you can simply rest beneath the same sky that countless generations once watched, while the planet continues its slow journey through time. The question can remain open. Were we the first? Perhaps, perhaps not. But until evidence tells us otherwise, humanity remains the only technological civilization we know to have existed on Earth. And that alone is a remarkable thing to contemplate. Good night, and rest well.